All right, this is problem 11-3, and a pretty easy one at that. Just go ahead. It says that there's an auto which has a spring that's supporting part of the car's weight, and what happens is that somebody jumps on the car, I suppose, and so the car vibrates up and down. And the question then is, what is the period of the motion of this car? Okay, easy enough. What do we start with always? Picture. Come in. Come in. We start with a picture. In case you don't know, that's a car. I can't tell you what year it's from, but it's a car. This car has a particular mass, which is given, and it has these springs. And so the car will bounce up and down in the springs. And in effect, each spring supports a quarter of the mass of the car. So then the question becomes, what is the period of motion of this car really is being supported by these springs? And so we have a formula for that right out of the book, period. Is 2 pi times the square root of m over k. Oh boy, do we know all that stuff? Well, it says that this is an 1,100 kilogram car, but of course only a quarter of it is going to be supported by the spring. So then the mass is 1,100 kilograms divided by 4. And what's the k? Oops. This is equal to that, isn't it? 1,100 kilograms over 4 divided by, what's the k? It says 3 times 10 to the 4th newtons per meter. So that's the spring constant of the car spring. Okay, so now this turns out into a pure plug and chug. Good morning. And the plug and chug yields an answer which it says is 0.602 seconds. Ever been in a car that's bouncing up and down? 0.602 seconds? Probably pretty annoying. Yeah, well, that does happen, doesn't it? Okay.
Yes!